first two definitions, a parameter is the actual value for a characteristic of a population. A statistic is an estimate of the population's parameter based on a sample. They actually give you an example, the average rate. So if you look at the paragraph above it, study of statistics to predict. We have like the average rate of 1-year-old boys. It says a statistician may predict the average weight of a 1-year-old boy in the United States based on a sample of 300 1-year-old boys. The larger overall set being considered is the population. The sample is a carefully selected subset of the population. So they take 300 random children at 1 year old, and you do have to have variables the same. So you'll notice they said boys. Boys grow at a different rate than girls. And so you're going to find a growth chart for boys and a growth chart for girls, because if they intermingled those, you're going to skew your information. It's not going to be specific enough. However, they're not going to take every single boy in the entire United States and take their weight at 1 year old. What they're going to do is they're going to get a sample. And so the sample is going to provide the statistic that they use to estimate. But the actual weight of those 300 boys is the parameter. Okay, and so if you read on, it'll say the parameter of the population is the average rate of that 300 boys. Then they're going to use that statistic to predict what an average 1-year-old boy should be and where in that he's going to fall. And so that's where you're going to get like percentiles and stuff like that for different age levels. And it helps doctors. Like and honestly, they look at it overall, realizing that everyone is created differently, right? But they track it to say, okay, are they growing at least at a steady rate if they're in this particular percentile? Or did we have a really big drop off from the national average that we have? It helps them medically make decisions. And so you're going to see this a ton in things like science, where they're using a small sample to predict. And so that's what those two are. So the first thing we're going to do is just talk about parameter versus statistic. State whether each characteristic is a parameter or a statistic. Explain your reasoning. In a study of the health of cats in humane societies, the average weight of cats at a local humane society was found. So they are studying all cats, and they're using the weights of cats at one specific animal society. What are they doing? They're using a statistic, right? So they're not taking the weight of every single cat at every single humane society. This is a statistic. All right, look at the next one. When reviewing the performance of students in the university's Calc 1 course, Dr. Holcomb found the range of homework averages for all the students in the 6 sections of the class. What has he done? That's a parameter. He actually did gather the information for every single one of those. Here we have measurement levels. So there's different words that you're going to hear in terms of information and data that's collected. Nominal data represents unordered groups. So they give examples: political parties, eye colors, gender. If I lined you up if I said line up by eye color, you'd be like, what does that mean, right? Like we can group by eye color, but there's definitely unordered, right? But if I said then line up by height, all of a sudden you would probably at least know either highest to lowest or lowest to highest. You would know that. So nominal is going to be unordered. Ordinal. So the next one represents categories within a set without indicating the distance. For example, customer satisfaction rating, class rank. So ordinal is going to not tell me the intervals basically in between the values. So class rank is ordered, but there's not necessarily a set interval. So it's not like from here to here is first, from here to here is second, from here to here is third. Okay. Interval. Distances without an absolute zero. But you will have set intervals here. So Fahrenheit temperature, time of day. Time of day does start over. So in my brain, I think there is a zero. Fahrenheit is when they say absolute zero, don't think about that in necessarily terms. It can keep going one way or the other. And if you think about time, it just keeps cycling, right? But it is intervaled. Like we can interval it by hour or by minute or by second, right? And those are set things. They're not like customer satisfaction, which could be 4.3 here, 5 here. Like there's no set what's going on. Ratio, distances with an absolute zero. Example, test scores, precipitation, income, height. All right, so with a test score, you're not going to hopefully get a negative test score, right? There is a definite cutoff point where it starts. There's a starting point, and then it goes from there. Precipitation, they're not going to say it rained -3 inches today. That's very odd, right? So there is a definite bottom and then something from that point on. Again, and the ratio is not necessarily going to be intervaled, right? I mean, that's not something that is set in stone. So let's look at identifying the levels here. State the level of measurement for each characteristic. Explain your reasoning. So we have a grade point average. Does this have a bottom?
Yes.
All right, grade point average. So do we have a starting point, a bottom? Yes, we do. So what do you think this one's going to be? So this one is going to be ratio. We start at a specific point. Place in a race.
That would be ordinal.
This is going to be ordinal. So it is ordered, and that's how I kind of think about it. However, it is not intervaled. Like you could have someone, there is no set intervals between first, second, and third when you're in a race. It's just what it is. Favorite professional baseball team. Nominal. That is nominal. Like that's gonna depend on the person and your group that you sample, right? So this one's gonna be nominal. No order. Yeah, when you think of day of the week, this is a measurement that you're going to have set actual divisions between them. Mm-hmm. All right, they have given us some information here. It says grade A, B, C, D, and F. Frequency 4, 7, 10, 3, and 1. Create a bar graph and a pie chart illustrating the grades on a statistics test. All right, so a couple things about graphs. They do no good if you do not label them. Okay, let's just start there. So if someone presents a graph to you and there are no labels, just stop there. Like, what are you telling me? Like, you know what I mean? That's useless information. So you'll notice a couple things here. First, they told us what it was, and then we have some information. This is the number of students. This is the grade, right? And really, I probably would have labeled that as well. I probably would have said letter grade, number of students, but that's just me, all right? Bar graphs are pretty straightforward. Hopefully you remember those from like, I don't know, don't y'all start these in elementary school, right? So bar graphs are really basic. You are just telling me a count per each section. So there were 2 A's. There were, I'm gonna guess 5, okay? The thing about a bar graph is that if it is talking about something that would not have a decimal, it's literally a count for a bar graph. So you're not going to have 1.5 typically on a bar graph if this is a count that we're doing. So you'll notice they went 2, 4, 6 because you can assume if it's in between 4 and 6, it's going to be 5. If it's between 6 and 8, it's going to be 7, right? So we can assume that there were 7, 10. We can assume that this was 3. We can assume that this was 1. All right, because we're talking about a number of students and they can't get both grades. All right. Pie charts break it up not into frequencies. So this is frequency. This is going to be a 1, 2, 3, 4, 1, 2, 3, 4. This is a count, a tally almost. This is going to break it up into percentages of the total. So if I had 4 A's, you'll notice that they listed it and then they get a total. So we have 4 out of 25, which gave us 16%. This right here, how do you think they got him?
They did 360 divided by the total and then multiplied by the frequency.
Right, or times 16%, yes. So you take 360 by the percentage, which is what that's going to give you, right? Dividing and multiplying. So if you take your percentage that you've calculated, that's going to tell you how much of the pie you have, right? Because a pie chart literally represents a full circle and how much of the circle do you have. A full circle is 360 degrees. You are going to then do it based off of that. They have a stem and leaf, which hence the term. It's stem, leaf, I don't know. And then a dot plot. I'm going to let you guess which one is which. All right. There we go. All right. Think of stem and leaf as exactly that. You have a stem with multiple leaves coming off the same stem. All right. For stems, you do have to identify what the stem is. Typically, it is going to be one digit, but that's not always the case. You could have it in hundreds, and then you're not going to do one and then several digits after the 100. You may do 100 and do 2 digits. Like it just depends on how you set up the stem and leaf. So, for example, we have the 58 here. We have a 5 and an 8. And then somewhere in all this craziness, we have a 59. That's the 5 and the 9. So the stem represents whatever segment you have separated it to mean. And then the leaves represent the rest of it. I will also say, and they don't have it here, but there's usually a legend on a stem and leaf. What do I mean by legend? So the legend will typically give you one example. So very often you'll see somewhere off the stem and leaf something like this, and that does this, right? And they actually define what one of them means so you can then interpret the rest of it. So very often you'll see a legend on those. For the dot, that is like a tick mark. Think of it that way. So that's just telling you how many of each one. We have 158. I'm going to assume somewhere in here we have 2 60s. If I can find them. There we go. 60 and 60, right? So it's literally a count of how many you have. Out that the stem repeats. So you are going to list, you'll notice like here, there's 2 dots for 60. That's because that's the same reason there's 2 zeros here. You don't just assume, all right, I already wrote it once, I don't need to write it again. You represent every single piece of your information. They'll very often give you these and then ask for like a mean, median, mode type question. And so then you have to say, oh, 58 plus 59 plus 60 plus 60 plus 61 plus 62 plus 62. Like you have to add it every time that it's accounted for. Your mean, median, and your median, whatever. You have to count all of those dots or all of those stem and leaf to figure out where your middle is. And so that's usually the ones that they're going to ask about. They're going to hand you something like this and ask for another piece of information for you to glean from it. This is a back-to-back stem and leaf. This is when you have multiple sets of information and you want to put it all on the same. So they gave us ages of U.S. presidents and they divided it between the 1800s and the 1900s. So they just took the same stem and leaf, but they did 1800s on one side, 1900s on the other, right? And so again, if they wanted any type of average, if they want it for all of presidents, you need to go both directions and count all of them, right? Which makes median and mode a little bit of a pain when you're given it like this. Mean works the same, it doesn't matter, but the other two are kind of a pain if they wanted it overall. But this is a back-to-back, so you'll see it split. And again, very often you'll see a legend for this as well. So. So when it says frequency, it is literally counting, okay? How often did it happen? You'll notice they did like a check mark, and then they did a table based on the check mark. The last thing I want to talk about is Sturge's formula. Sturge's formula is when you break something up into intervals. It gives you this crazy little k equals 1 plus 3.3 log of n. All right, and that will actually give you the number of classes is what it's called. And then you're going to take your count and divide by that, your range. So you would take your highest and your lowest and divide by Sturge's number, and it will tell you what intervals to use. So you would use this little formula, and it's going to give you a number. You're always going to take that number and round up. All right, to the nearest, right? So this is 6.6, you're going to use 7. And then you're going to take your range and divide by it, and it'll tell you what your intervals should be, right? And that's how they came up with these intervals, which would be...
The formula is 1...
Is. Yeah, I'm hemming them.
Oh, yeah, my mom has to have that. I do not want to go to work tonight.
I'm sorry.
It's okay. We have to hem my...
Cooper has got to apply at Chick-fil-A. That's where he wants to go work.
I have a phone number. I mean, he can apply through the website, but I can just
Do
give
you
you the
get
phone number.
bonuses?
I do. I might get a bonus.
Jake-
Don't
Jacob-
apply yet.
Okay.
Jake got
Because
$100 for doing it.
don't apply yet. I'm gonna.
Do they like you?
They love me.
Okay. I'm just...
No, they love me.